Hello, grade 12s, and we're looking at trig. But before we get into like grade 12 trig, we're going to look at revising our grade 11 trig and possibly grade 10 as well. And so we'll see where these examples take us. So not going to cover everything from grade 11, but it's certainly going to get us thinking. So let's see. So it's going to be a bit more than just, oh, there's that's how we solve, and we're going to move on, but like we're thinking as we go. So 7 sine theta plus 4 equals 0, and cos theta is greater than 0. Determine tan theta without a calculator. Okay, this is one of those without a calculator where we mustn't actually use our calculator. And I think the key bit actually, the way this should be phrased is without finding out what theta is. We don't care what the angle theta is. We could work that out, but we don't want to work out what theta is. What we want to do is draw ourselves a Cartesian plane and see where on the Cartesian plane we are. So one of those things that helps us see is, when are the various trig ratios positive? Well, they're all positive up here in quadrant 1, and then whichever mnemonic helps you remember that cos is positive here, sine, tan, etc. in the various quadrants. I normally call it cast, but the various great mnemonics out there. Okay, so it tells us that cos theta is positive. Well, that tells us that we can't be in the tan kind of quadrant, and we're also not going to be over there. Okay, so those two quadrants are out. Goodbye. And let's see what the other bit of information tells us. 7 sine theta plus 4 equals 0. It would be nice if we had that in the form sine theta equals some sort of fraction. Wouldn't that be a little bit neater? Well, let's just work our equation and manipulate it so that it looks like that. So I think that if we subtract 4 from both sides, we'll have that. And then if we divide both sides by 7, we'll have exactly what we want. Negative 4 over 7. Okay, so what that's sneakily done is told us that sine is negative. Okay, well, if sine is negative, well, then we can get rid of that one over there. And we must therefore be in the bottom quadrant, because sine is negative is also down here, but we already crossed that one out. Okay, so let's draw ourselves our point down here. I don't know, it's up to you how much scale you want. I always think, sure, minus 4 over 7. Well, if you remember that sine theta is y over r. Wait, do you remember that? Oh, and how do we remember that? Was there shade your rear and another fun mnemonic? I think skipping another way of mnemonic is just to go, let's draw our triangle in the first quadrant and go, well, I know that's x, y, and r. And I remember saying so, ka, toa 1,000 million times. And sine is opposite over hypotenuse, y over r. Nice conceptual way of remembering it. And then it just relies on one mnemonic there. Okay, so that's one way to do it. So therefore, we know that this is kind of y over r. So we can put it there for reference. Just say, well, our radius must always be a positive thing. Our y is negative. Things are looking like they're fitting together nicely. So our y value is 4. I was talking about scale earlier and saying, you know what, I'm just going to draw it there. I don't know if it should be higher or lower. And remember that theta is the angle all the way around it, not the little angle. That's theta, that whole angle there, which must be somewhere between 270 and 360. We don't care what it is exactly, but it must be kind of in that range. Okay, let's rub some of these beautiful drawings away. Goodbye to you, to you, to you. And I think we've still got all the information we need. With a bit of luck, let's see if we can move that up there as well. Okay, so we've got our drawing. Let's just finish it off and say, well, if we draw kind of up to the x-axis, then we can possibly see that things are a bit better and go, this y value here is negative 4. The distance is 4, but I always like to put the negative there, so don't forget it. And this is 7, that's our radius. Well, then if we could just work out what our x value is, which is a positive value, we can work out what tan theta is, because we know tan theta is y over x. Well, that was meant to be a triangle. It wasn't a great one, was it? And just in the first quadrant, opposite over adjacent, y over x. So if we can work out what x is, we're good to go. Okay, so as I said, you might have gone, oh yes, now I know how to do this. That was all easy, but we've covered a whole lot of stuff at the same time. So to work out x, hey look, right angle triangle, our dear old friend Pythagoras, who, we name a theorem after. I say that because, we've got evidence of the Babylonians doing this 1,000 years before and whatever else, but the Pythagoreans seem to have done quite a lot for mathematics and formalized the discipline quite a lot. So let's honor him with a theorem and say that x squared plus y squared equals r squared. Okay, we've already shown in our diagram that x must be positive, so x is just, well, we know that r was 7, so it's just 7 squared minus 4 squared. Somewhere around here I have one of these trusty things called a calculator, because I'm too lazy to work this out. So we got 7 squared minus 4 squared equals 33. So we're going to take the square root of 33 as x. So therefore, tan theta equals, what do we say, y over x. So tan theta must be negative 4 over root 33. Okay, and our final kind of check for what we're doing there is, well, tan is negative from what we've done. Yes, that makes sense that tan is negative in quadrant 4. Okay, so as I said, quite a few things that we looked at there. Hopefully some of them useful. Of course, all of them fantastically interesting. I'll see you in the next one.